Hi everyone. In this video I am going to explain you a topic called phase delay and phase jitter. You know very well delay. Okay, by seeing the name one can understand delay is nothing but some retardation, some gap between the input and output. Okay, here also it is the same delay. Phase delay is nothing but the time gap, the gap or application of input and generation of output. That gap is nothing but phase delay. Now, what is phase jitter? Phase jitter is nothing but it is due to some noise in the system. Okay, the delay, the same phase delay is occurred because of the noise generated within the system. That type of delay is nothing but phase jitter. I will write what is the definition of phase delay and phase jitter here. See, the phase delay is nothing but the delay between the input pulse to a divider and the output pulse is referred to as phase delay Okay, suppose if you are taking any divider circuit, here we are applying the input and this is the output. Okay, so this is the application of input and it is the time t0. After some time the output is generated. This is t1. This time gap is nothing but phase delay. Okay, hope you understand from this diagram. Now, what is phase jitter? See, some extraneous signals like some extra signals may be coupled unintentionally. We are not adding them unintentionally into this divider. Such a signal may have an influence on the exact moment at which the basic waveform reaches the cutoff. So in that case, the phase delay may be subjected to the periodic variations. So this particular phase delay may be varied. All these factors which affect the phase delay give rise to a term called phase jitter. Due to extra signals added to the divider, all these are unintentionally that will violate the phase delay which is originally occurred. All these factors which affect the phase delay give rise to what is termed phase jitter. Hope you understand. Okay, some extra signals are being added to that original divider. Because of that, there is a variation in the phase delay. That particular factors which are affecting this concept of phase delay is nothing but phase jitter. Okay, now let us consider an example. Consider a circuit or an example with a divider circuit followed by a gating waveform generator, whose output is given to a sampling gate, Okay, let us constitute this diagram. See here, it is a divider. What is the purpose of divider? In this divider, there are actually n number of pulses we are giving. Among these n number of pulses, see, input is consisting of n number of pulses. Among these n number of pulses, out of these n number of pulses, one number will be chosen. One pulse will be chosen. Only one pulse will be chosen at the output. That is the purpose of divider. Okay, divider will divide the n number of pulses, the input pulses by n. Okay, divider will divide input number of pulses by n. Okay, that means if there are n number of pulses, one pulse will be at the output. This one pulse will energize the gating waveform so that the gating waveform generator will generate a gating pulse. Gating waveform generator will give you a gating pulse. Gating pulse generator is nothing but it needs a triggering pulse. At that particular triggering pulse initiated, automatically a gating pulse is generated. Because of this gating pulse, see, the same input we are applying n number of pulses to the sampling gate as well. N number of pulses. The same n number of pulses we are applying to the divider and as well as to the sampling gate. Out of these n number of pulses, whichever sample or pulse that comes under this gating pulse in this particular time period Tg, the time period of this gating pulse is termed as Tg. In this particular Tg, whichever pulse out of these n number of pulses, whichever pulse comes under this Tg, that will be sent to the output. Output is also one pulse, but this pulse may not be equal to this one pulse. Hope you understand. Because whichever the pulse that is there in this particular duration Tg, that pulse will be sent to the output. All the remaining pulses are eliminated. Okay, sampling gate is not like your AND gate, OR gate or any type of logic gate. Sampling gate is the one which sends the input sample to the output whenever a triggering pulse is given, whenever a gating pulse is given. Okay, now let us see with respect to the waveforms. See, this is the number of waveforms, n number of input pulses. First waveform indicates n number of input pulses. Out of these n number of inputs, see, n 1, 2, 3, 4 and so on, n again 1, 2, 3, 4 and so on, n. All these n number of pulses are continuously repeating for infinite duration. Now, the second waveform is, see, here I indicates input. Second one is the output of divider output. This is the input. Okay, so divider output, as I said, out of these n number of pulses, only one pulse will be sent because it divides the input number of pulses by n. Okay, n is to 1 divider. Okay, so it is only let us assume that only nth pulse is coming. This is nth pulse, again this nth pulse, again wherever the nth pulse is there, that nth pulse will come. Hope you understand. Out of n pulses, only one pulse is coming. In this case, I have assumed n is the pulse number. Okay, that may be 1, 2, 3 and so on, any number of pulse. Now, whenever the nth pulse is given, where this nth pulse is going? Here. D output is going to the gating waveform generator. Whenever the nth pulse is given to the gating waveform generator, automatically the gating waveform will be starting to generate. It is started to generate. It is the output of gating pulse or gating waveform generator. Okay, so automatically when this pulse is given, a gating waveform is originated. This is the gating pulse. Okay, now this gating waveform, where we are giving, this gating waveform is applied to sampling gate, is applied to sampling gate. So whenever the sampling gate is applied with this gating pulse, this gate opens, and whichever the pulse is waiting at that moment, that will be sent to the output. Okay, so at this particular moment, see, go to the input, because the same input is applied to the sampling gate as well. Okay, so in this particular duration we are having the first pulse. In this particular duration we are having only first pulse, so that's why first pulse is going to the output. This is output. Again, after some time nth pulse is coming. Whenever nth pulse is applied to that sampling gating pulse generator, so gating pulse is generated, and at this particular point we are having one, so first pulse is going to the output. Okay, so this is the normal operation of a divider, gating waveform generator, and a sampling gate. Now, what could be the condition for the generation of this gating pulse? Gating pulse. The condition for this one is, the condition for proper transmission, the condition for proper transmission is, this is very important, Tp less than Tg less than 2 Tp. Tp, input pulse period. It should be less than the gating pulse, and that is also less than 2 times the pulse period. That means we have to choose the gating pulse in such a way that it should be less than T and 2 Tp. Okay, then only we can have that particular output, whatever I have explained in the previous slide. Okay, that means it is enough, that is, it is enough if Tg is longer than the interval between the pulses Tp and shorter than the interval between the alternate pulses, between the alternate pulses. Okay, so this is the concept of phase delay and phase jitters. In the next video I will explain about the synchronization of a sweep circuit with symmetrical signals. Symmetrical signals are nothing but continuous signals, okay, like sinusoidal waveform. Okay, thank you.